Hello everyone. For this tutorial video, I'd like to explain how you can find the derivatives and therefore tangent lines of polar functions. Although unfortunately, it will be more complicated than you might initially think, and we will see why this is later in the video. In particular, we see the problem is that the derivative is written as change in y over change in x. But with polar functions we do not have y or x, we have radius and degree instead. So we will have to go back to using parametric equations in order to figure out how to represent x and y with reference to the angle at the same time. In particular, we remember that x can be expressed as radius times cosine of angle and y as radius times sine of angle. So we use these parametric equations where the parameter is the angle. We see if we express r as a function of angle, as that is what it is in polar coordinates, it follows that change in x with respect to change in angle must be the derivative of function of angle times cosine of degree minus function of angle times sine of degree by the product rule, and remembering the derivative of cosine is negative sine, and by similar logic, the change in y over the change in angle must be the derivative of function of angle times sine of angle plus function of angle times cosine of angle. We now see that we can get this in terms of change in y over change in x by writing change in y over change in angle over change in x over change in angle, because the change in angles cancel out. So we have seen that the exact formula for the derivative of a polar function is very messy, because of the fact the derivative is defined using rectangular coordinates, so we had to convert to those first. Now that we have figured out the derivative and therefore the slope of a tangent line of a polar function, we can figure out the integral of a polar function next, which will tell us the area under its curve, just like for parametric equations and for normal rectangular functions. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.